Okay, so we are going to look at the last piece of information that we need for this unit, and that is using the quadratic formula. So today we took a look at a lot of the videos that'll get us there. We can sing our little ditty and learn the formula with the song. So let's do a little bit of review before we move into quadratic formulas. So solving a quadratic function means to find the values of x, or your x-intercepts. And your x-intercepts are where it crosses your x-axis. There will be either one solution, two solutions, or no solutions. So you can have any three of those. Ways to solve. So here's our four ways to solve. We can graph it. The solutions are where the graph, the parabola, crosses the x-axis. These are your x-intercepts. Those are the solutions when I graph. So if I take a look, for example, at a positive parabola facing upward and it doesn't cross, this would be no solution, because there are no times where it crosses the x-axis. Or it could also cross as a positive parabola at two spots. So my solution are these points right here, the x values, where it crosses. So here I have two solutions. I could also have my negative parabolas. I could have no solutions, or I could have two solutions. And the solutions are the x values where it crosses the x-intercept. That's two solutions. You could also have one solution. So if I have a positive parabola, it's going to touch right there at 0, 0. So I have one solution. And conversely, you could have a negative quadratic, which again crosses right there at that one point. One solution, where y is 0, and then you find the x values. That's method one. Or you could take the square root. You use the square root method when no b term. When there is not a variable, it's only a square and a constant. The steps are to isolate the variable. That means get the variable by itself as much as you can. Get it as naked as you can on one side. And then take the square root of both sides. Remember, cannot have a negative under radical. So no negatives under the radical automatically means no solutions. You'll learn in Algebra 2 that it's not necessarily no solutions. It's no real solutions. They're going to be non-real numbers that you can deal with. So let's take a look at this example. In order to start getting the variable isolated, you can see I have no b term. There's no t by itself in between. I start to isolate the square, so that means I need to add 81 to both sides, and I get 49t squared equals 81. I just added 81 to both sides. In order to get t by itself, I need to then, inverse operations tells me to divide. So I get t squared equals 81 divided by 49. Hopefully what we're able to see is that, hey, 81 is a square, and so is 49. So when I then take the square root of everything, I can take the square root of 81 over the square root of 9. So this becomes t is equal to plus or minus. The square root of 81 is 9, and the square root of 49 is 7. So I have a positive 9/7 and I have a negative 9/7 as my two solutions. That's method 2. Method 3 is to factor. Lots of ways to factor. We could factor using greatest common factor. We can factor using a times c. We can factor by making tables. All kinds of ways to factor. So you've got to be able to know how to factor. Okay, so factoring you need to know how to do, and then once you factor, you first factor, then use zero product property to solve for each x, or each variable. So let's take a look. So we have this quadratic equation. We need to be in standard form, so I need to move everything over. So that means I need to subtract 6 from both sides. I end up with 15a squared minus a minus 6 equals 0. Then we know that the a, I have an a term and a c term, so a times c is 90. That gets me to 1. So the values would be 10 and 9. 10 times 9 equals 90, and 10 minus 9 equals 1. So I know it's negative in the middle, so the 10 is going to be negative and the y is going to be positive. So since we have an a term, then we need to rewrite and group in factors. So minus 10a plus a 9a minus 6 equals 0. So the equals 0 is just telling us we're solving for a value. But we're not going to do anything differently. We're still just factoring this stuff. Once we get down to the factors, then we'll set them equal individually to a. So I'm going to group, and then I'm going to factor. That's a 9a. So 15 and 10, that means 5 comes out. So I have a 5a comes out. I'm left with 3a minus 2. We know 3a minus 2 goes over here automatically. Something times negative 2 got me to negative 6. We'll call that a positive 3. Positive 3 times 3 is 9, so we're good there. So I know that we have 5a plus 3 times 3a minus 2. All of that is still set equal to 0. The zero product property then tells me set each of these pieces separately equal to 0. 5a plus 3 equals 0. Subtract 3 and divide by 5 is going to get a by itself, so I get negative 3 over 5. 3a minus 2 equals 0. I'm going to add 2 and ultimately divide by 3, so I'm going to a equals 2/3. We need to know how to factor. If you're still struggling with that, make sure you get your booty in here so that we can work on it. And our last method that we're going to learn, those other methods that you will learn in Algebra 2, is the quadratic formula. And our video showed, hey, I still have my qualification that a can't be 0, because then I would end up with a linear equation here. And we can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, when you substitute in, be careful with your negative signs. So make sure you're putting stuff in parentheses and then simplify. You still need to be in standard form, which means everything needs to be moved over to one side. So I'm going to rewrite this as 2x squared plus 3x. I must have to subtract 5 from both sides to get my pieces. Then I know that a equals 2, b equals 3, and c equals negative 5. And then it just becomes a matter of substituting the pieces. So x is equal to a negative b. b is 3. So I'm going to put b in parentheses. Plus or minus, that's how I'm going to get my two possible answers, the square root of b squared. So anytime I substitute, I always put in parentheses. Minus, 4ac. 4 times our a, which is 2, times c, which is negative 5. We're just being thorough, nice and slow. Over 2 times a, which is 2. And then it's just a matter of simplifying. I know I have a negative times a positive, so that's just going to be negative 3, plus or minus, and I start to simplify the determinant stuff underneath here. 3 squared is 9. I have a negative times a negative, so since there's two negatives, it's ultimately going to be a positive. 4 times 2 is 8. 8 times 5 is 40. All over 2 times 2, which is 4. These take a lot of room and a lot of steps. Don't skip steps, that's where you're going to make mistakes. Negative 3 plus or minus the square root of 49 all over 4. So I can still continue to simplify this as negative 3 plus or minus the square root of 49. Well, what's the square root of 49? 7 all over 4. Once I've simplified all the radicals and all the denominator numerator stuff, then I end up having a plus or minus up here though. I need to split it into two different expressions. Negative 3 plus 7 over 4, or negative 3 minus 7, because I have a plus or a minus. Minus 7 over 4, and simplify. Negative 3 plus 7 is 4, so I get 4 over 4, which is equal to 1. Negative 3 minus 7 is a negative 10 over 4, which reduces to negative 5 over 2. So x is equal to 1 and negative 5 over 2. These are the two places my parabola crosses the x-axis when it's graphed. All right, let's take a look at a couple more before I let you guys practice on your own. We're going to use a quadratic formula. Sometimes we won't have to. Sometimes you'll be able to factor or do an easier method, but we're practicing the quadratic formula. So we need to make sure we are in standard form, which means I need to subtract my 2x. X squared minus 2x minus 8. It needs to be in descending order so that I have standard form. So I moved my 2x into the middle. That means a is equal to 1, b is equal to negative 2, and c is equal to negative 8. And then I just substitute it in. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b is a negative 2. See how I substitute in with parentheses? Plus or minus the square root of negative 2 squared minus 4 times a is 1, times c, which is negative 8. All over 2 times 1. So I just simplify. Negative times a negative is a positive 2, plus or minus the square root. Negative 2 times negative 2 is a positive 4. Negative times a negative is a positive. 4 times 1 is 4. 4 times 8 is 32. So I get a positive 32 over 2. Negative 2 plus or minus 4 plus 32 is the square root of 36 over 2. I should simplify my radical as much as I can before I move on. So since I can simplify, negative 2 plus or minus the square root of 36 is 6 over 2. Once I'm completely simplified, then I can break up into two expressions. Negative 2 plus 6, I'm handling the plus piece, over 2, or negative 2 minus 6 over 2. Negative 2 plus 6 is 4. 4 divided by 2. Oh no, negative 2. Do we have a negative? Negative times a negative is a positive, so I don't know how I got negative. So let's go back and fix that. So my reality check can go, wait a minute, where did the negative come from? Because a negative times a negative is a positive, so I should have had a positive carried down. Now I have 2 plus 6, which is 8, divided by 2 equals 4. And negative 8 divided by 2. Nope, that's positive 2. Sorry, guys. Positive 2 minus 6 is a negative 4. Divided by 2 is a negative 2. So x is equal to 4 and negative 2. Those are the two places that it crosses my x-axis when I graph it. All right, let's try another one. See if I can not screw up your guys' signs. So again, I got to move my 8 over. So I know I have 2n squared minus 6n minus 8 equals 0. Now I can start to solve it. A equals 2, b equals negative 6, c equals negative 8. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Then I substitute. I have a negative, and then I have to substitute in my negative 6. So there's our positive 6. Don't let me screw that up. Plus or minus negative 6 squared minus 4 times 2 times c, which is negative 8. all over, don't forget your denominator because I see that a lot, 2 times 2. So that is equal to a negative times a negative is a positive 6 plus or minus 6 times 6 is 36. Negative times a negative is a positive. 4 times 2 is 8. 8 times 8 is 64. All over 4. So I'm going to simplify over here. Right now I have 6 plus or minus the square root of 36 plus 64, which is 100, over 4. Square root of 100, we know is 10, so I can simplify that as 6 plus or minus 10 over 4. Now that I'm completely simplified, 6 plus 10 over 4, and 6 minus 10 over 4. That's 16 over 4, which is equal to 4. 6 minus 10 is a negative 4 over 4, which is equal to negative 1. So x is equal to 4 and negative 1. Okay, pause the video. You try the next couple. If you need extra space, you can do it on a separate sheet of paper. Okay, those are the answers that you should have gotten. If you did not, pause the video, go ahead and rework them, see if you can figure out where your mistake was, or start from scratch and rework them again. Make sure you come in with questions tomorrow if you have them. So let's take a look at choosing a method, because what we want to do is choose the most efficient method. So sometimes it's better to use squaring, taking the square root. Sometimes it's better to factor, and sometimes it's better to take the quadratic formula. So we need to be able to figure out which one's which. So if I'm going to look and see which one I want to use, if I can factor, I like to factor, so I'm going to look and see if I can factor. I would need the factors of 11, it's prime, so the only factors are 11 and 1, that get me to 3. Well, if I subtract them, I get 10. If I add them, I get 12. So I can't factor. Since I cannot factor, I need to use the quadratic equation. Quadratic formula. Because can't factor. Let's take a look over here. Oh, wait a minute, I don't have a b term, so this is really 9d squared equals a positive 100, so I can start to solve this using the square root. Because no b term. So it's easier to solve. I could also use the quadratic formula for this, but that's a lot more work for something that I can use taking the square root. So you guys try the next couple. Okay, so we should be able to say 16 times 3 is 18. Factors of 18 that get me to 11. Well, that's 9 and 2. They both have to be negative because I need negative 11. So I need negative 9 and negative 2. But if I'm multiplying negative 9 and negative 2, I end up with a positive 3, not a negative 3. So I cannot factor this, so I have to use the quadratic equation. Over here, this is easy to factor. It's easily factored into two binomials because I have 6. So 5 and 1, one's positive, one's negative, or 6 and 1, but one's positive, one's negative, like it's good. All right, last piece of information. Let's take a look at what's called the discriminant. You can use the discriminant. Sounds like a fancy word. You can use the discriminant to determine the number of real number solutions of a quadratic. So this just tells us the number of solutions, not what the solutions are, but how many there are. So it can help weed out if there's no solutions at all, why bother doing all that quadratic formula work? It comes from the quadratic formula. So we can find out if there's one solution, two solutions, or no solutions. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the expression under the radical. It is just the stuff underneath without the radical. It is b squared minus 4ac. there are some rules that if I use this and the numbers come out a specific way, then I know if it's one solution, two solutions, or no solutions at all. So we're going to use the discriminant. Here's our little cheat sheet table that shows us what the rules are. The discriminant is b squared minus 4ac. If b squared minus 4ac is greater than 0, i.e. the number is positive when I substitute in a, b, and c, then I have a discriminant that is positive. I end up with a graph that looks like this. So I'm going to end up with a graph that crosses the x-axis twice. So I end up with 2 real number solutions. So 2 solutions. If, however, my b squared minus 4ac is equal to 0, you can see it sits right at 1 point on the x-axis. So you end up with 1 solution. So if my discriminant is equal to 0, 1. If it's positive or greater than 0, I have 2. But if b squared minus 4ac is less than 0, which means the number after I substitute in is negative, then the graph doesn't cross the x-axis at all. Whether it's a positive quadratic or a negative, it's going to be either above or below the x-axis. No solution. That's also when the square root of a negative number. Okay? So that's where that's coming from, because we're looking at just the stuff underneath. So if it's negative, hey, if I'm taking the square root of a negative, I automatically know it's no solution. So let's find the number of real solutions. So we are finding the number of. So find number of. If you see that, you automatically know that we're using b squared minus 4ac. So I'm going to identify a equals 1, b equals negative 10, c equals 9. And then I just substitute in the pieces. b squared minus 4ac. b is negative 10. Negative 10 squared minus 4 times 1 times 9. Watching your signs. Negative times a negative is a positive. 10 times 10 is 100. 4 times 9 is 36. So it equals 64. 64 is not an answer. Positive. It's a positive number, so 2 solutions. 64 is not my solutions. It just tells me it's positive, it's above 1, it's above 0, so I have 2 solutions. Then I can go find what those 2 solutions are. Let's try this one. A is equal to negative 5, b is equal to negative 2, and c equals negative 14. So b squared minus 4ac, b squared negative 2. Negative 2 squared minus 4 times negative 5 times negative 14. Negative 2 times negative 2 is a positive 4. I end up with a negative times a negative times a negative. I have an odd number of negatives, so I know I'm going to have a negative. Then I have something big numbers. 4 times 5 is 20. Well, 4 minus 20 is already negative. I know this is negative. I don't need to finish and figure out what the actual number is. I can use my mental math to see that, hey, I have a negative number, so I'm going to have no solutions. And one more. A equals 1, b equals 10, c equals 25. b squared minus 4ac. b is 10. 10 squared minus 4 times 1 times 25. So all I did was substitute in a, b, and c. 10 squared we already know is 100. Minus, I don't have anything else, so I'm going to do minus, so I know it's negative. And 4 times 25, well, 4 quarters is $1, so I have 100 pennies. 100 minus 100, well, that's 0. If it's equal to 0, then I know there is one solution. The solution is not 0 necessarily. It just means I only have one solution to find. All right, pause the video. Try yours. All right, there are the answers to yours. You should show some work. When I come around and check, I'm going to be looking for work. If you didn't get these, make sure you star the ones that we need to talk about tomorrow. I'll see you in class.